A very good morning to all of you. Myself, Dr. Shrinkhala from School of Management Sciences, Lucknow. The topic of my lecture is semiconductors. Now, what are semiconductors? Semiconductors are the devices which work both as conductors, as insulators, or something in between them. So, the elements of periodic table, here we see that the elements of group 4A, especially silicon and germanium, they behave as semiconductors. Now the question arises that why these elements of group 4A behave as semiconductors. So here we see that these elements have got 4 electrons in their outermost shell, and with the help of these 4 electrons, they easily form covalent bonds with the neighboring silicon atoms, giving rise to a crystal lattice. Now here we see that there is a vast difference between metals, semiconductors and insulators. Metals have no energy gap in between valence and conduction band, and therefore electrons can easily jump from valence to conduction band. In insulators, here we see that there is a large amount of energy gap in between the valence and conduction band, and therefore movement of electrons from valence to conduction band becomes quite difficult. But in semiconductors, here we see that there is a small energy gap in between the valence and conduction band, and therefore at 0 degree Kelvin, when the whole molecular motion ceases, the electrons cannot jump from valence to conduction band, and at that particular period of time, these semiconductors behave as insulators. But when a small input of energy is given or a small amount of rise in temperature takes place, these electrons easily jump from valence to conduction band, making these semiconductors a very good conductors. And such kind of semiconductors are called intrinsic semiconductors. But now if we have to increase the conductivity of these semiconductors, we will have to add some kind of impurities or other kind of atoms. Such kind of semiconductors are known as extrinsic semiconductors, and this process of addition of impurities is called doping. Now, there are two kinds of extrinsic semiconductors. First is negative type of extrinsic semiconductors, which are formed from pentavalent atoms and pentavalent atoms of group 4A. Here we see arsenic has got pentavalent, means 5 electrons in its outermost shell, out of which 4 electrons it shares with the neighboring silicon atoms, leaving 1 electron free. So there are so many of free electrons in one crystal lattice. In p-type of semiconductors, these are known as positive type of semiconductors. These involve trivalent atoms. Trivalent atoms means atoms of group 3A. Here what happens is that these atoms have got 3 electrons in their outermost shell, which they share with the 4 electrons of silicon atom, leaving one positive hole or a gap, positive gap free. So there are large amount of positive holes in one crystal lattice. So we have got the conducting elements, which are there, two kinds of it. First is the electron and second is the hole. So the electrical conductivity takes place both with the help of hole or the electron, but the direction of conduction of electricity is in the direction of positive holes and in the reverse direction of electrons. That was all. Thank you so much.